Absolutely the opposite, the parallelogram opposite angles converse. Why?
Because first of all, like two of the angles are already like given, and then two
Mm-hmm.
of them aren't. So since the two that are given are congruent, that probably means that the other two are as well.
Well,
They're opposite, so.
remember, Teresa, we've got angle marks here and here. What does that tell us?
Oh, that they are congruent.
They are congruent. Very good. Okay. So we know that those two are congruent, and then it gives us the measure of these two. So these two have to be congruent as well. Okay. So it is the opposite angles converse. Excellent. What about number 2? Someone other than Teresa. What do you think, Samantha?
Me?
Yeah.
Parallelogram, opposite sides, converse,
Close.
not converse.
Juliana, what do you think?
Diagonals converse.
Ah, diagonals converse. No, were you going to say the same thing? Very good. What is the diagonals converse? Juliana, do you know what it actually says?
They bisect.
Ah, Samantha got it. They bisect each other. Do these bisect each other? How do we know?
They meet in the middle.
They meet in the middle.
They have congruent marks.
Ah, they have congruence marks. Do you see how each of these diagonals, so let's highlight each of them, one in red and one in blue. Do you see how they're cut perfectly in half by that point in the middle? Since they're cut in half, they bisect each other. That is the definition of the parallelogram diagonals converse. That's why we're using it. Parallelogram diagonals converse. Okay? All right, in today's lesson, guys, we are going to learn about 3 different specific types of parallelograms. We're going to learn about a rhombus, a rectangle, and a square, and the properties that come with those shapes. And you might be saying, oh my gosh, we're learning about rectangles. We've done rectangles since we were like little kids. Absolutely, but there's very specific things now that involve theorems that are true about rectangles and squares. Okay? All right, so let's jump to the next slide. Chapter 7, Section 4, Properties of Special Parallelograms. Go ahead and just put in here that we're talking about rhombuses, rhombus, rectangles, and squares. Okay? Rhombus, rectangle, and a square. Those are the 3 new shapes we're learning in this lesson. Okay? Okay, let's talk about exactly what they are. So their definitions. So a rectangle is a parallelogram with 4 right angles. That is the only stipulation for a rectangle. A rhombus is a parallelogram with 4 congruent sides. So all 4 of the sides are the same length. A square is a parallelogram with 4 right angles and 4 congruent sides. So a square is technically both a rectangle and a rhombus. Okay? A square fits under both categories, so it has to have all 4 same sides, all 4 right angles. And notice, guys, they are all parallelograms, okay? So underline the word parallelogram in each one. They're all parallelograms. So everything that held, all those theorems for parallelograms that we learned, those also hold for rhombuses, rectangles, and squares. Okay. Rhombus corollary, okay? A quadrilateral is a rhombus if and only if it has 4 congruent sides. We just talked about that. That's just the definition of a rhombus, okay? So it gives a little picture. All 4 of those sides are equivalent. Rectangle corollary. A quadrilateral is a rectangle if and only if it has 4 right angles. So as long as you have 4 right angles, you're a rectangle, okay? A square is a square if and only if it is a rhombus and a rectangle. So it has to have both. Squares are the most restrictive. If you want to put a little star, put most restrictive. You will come across the squares the least, okay? Because they're the most restricted. They have to be both. They have to have all 4 right angles and all 4 congruent sides. So keep in mind, guys, when we're talking about theorems that apply to rhombuses, they automatically apply to squares. And when we talk about theorems that apply to rectangles, they automatically apply to squares as well. All right, here's just a little diagram to help you guys like visualize it. So squares are in the middle because they fall under rhombuses and rectangles, okay? Now, not all rhombuses are rectangles, okay? If it's not a square, it's not a rectangle. So rhombuses, like the ones that you see on the left, see how not all 4 of their angles are 90 degrees, but each of their sides is the same length. And for rectangles, notice how all 4 of the angles are 90 degrees, but it's not necessary that all 4 of the sides are the same length. And then on the outside of your image, you've got parallelograms, where the only requirement are that opposite sides are parallel. Okay. Now we get into the theorems, okay? The first theorem that we're going to learn about is the rhombus diagonals theorem. That just says that if you've got a parallelogram that is a rhombus, its diagonals are perpendicular to each other. So when you draw the diagonals from like AC and BD, where they intersect is going to give you a 90-degree angle. That is true for rhombuses, okay? The rhombus opposite angles theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So in this case, each of those diagonals, the line from AC and the line from DB, notice how each of the angles on both sides of that diagonal are the same length, okay? It bisects each of the angles in half. And lastly, we've got the rectangle diagonals theorem. A parallelogram is a rectangle if and only if its diagonals are congruent. So the quadrilateral ABCD is a rectangle if and only if AC is congruent to BD. So not only do they get cut in half, right, like we saw in our warm-up, but they're also, all of those segments are going to be the same length if it's a rectangle. And just below this slide, guys, just put a little star and put all theorems above apply to what shape? Squares. Very good. Because squares are both rectangles and rhombuses. At the first 2 theorems that we learned about, the rhombus diagonals theorem and the rhombus opposite angles theorem. Do either of these tell us about that angle?
No.
Whoa, what just happened? Okay, quadrilateral ABCD, and again, guys, whoops, what just happened? Hold on.
Hey, what did it say about all theorems applying? What was it? What was the full thing?
Apply to squares. All right, we're back. I don't know what happened there. Okay. So in example 1, quadrilateral ABCD is a rhombus. Find the measure of each angle. And again, guys, these for some reason aren't printing very well, so we're gonna draw our image again down below. So just draw more of a parallelogram, so something that looks like this. And then these are your diagonals. This is A, D, B, C, and E. And this one is 62 degrees. So all we're giving, guys, is one angle and the fact that it is a rhombus. Now, take a look. If you need to go back to the last slide, we can start to fill in our rhombus with certain measures, okay? The first thing that this problem asks us for is ACD. Angle ACD. What do you guys think that angle needs to be? Very good, Teresa. 62 degrees. Why?
Because of the rhombus opposite angles theorem.
Good. That diagonal from A to C, it cuts that angle C and angle A in half completely, okay? So if one side is 62, the other side must be 62, okay? Now it also wants us to find DEC. From D to E to C. What is that angle going to be? Oops. That's this one right here. Well, let's take a look back at our theorems. For a rhombus, guys, each of these is going to be 90 degrees. Remember, the diagonals intersect at a 90-degree angle. They're all going to be perpendicular, okay? So at point E, all of the angles from point E are going to be perpendicular. They're going to be 90 degrees. So DEC is going to be 90. That's just the definition of a rhombus, okay? So because it told us that it's a rhombus, the intersection of AC and DB is going to be 90 degrees. All right, EDC. That's this angle right here. What's the measure of that one?
$62.
Not quite. Does anyone see it?
Is it 28?
Ah, how'd you get that?
180 minus 90 minus 62.
Good. There's a mini triangle in here. Do you guys see that? The little triangle in there down at the bottom. So all you had to do is take the 90 from the top, the 62 from the bottom, add them together and take that away from 180. So this was 180 minus 62 minus 90, which gives us 28. And that would be this angle EDC. Okay, and can anyone tell me what's ABC gonna be? That's this large angle over here. Close. So I agree that since this is 28, this is 28, and then that makes this 28, and this 28. So what's ABC?
56.
Good. The whole thing is going to be 56 degrees. Okay? Which is just 28 plus 28. Okay. Quadrilateral MNOP is a rectangle. Complete the following, okay? Guys, go ahead and cross out the N and the O and just put them over on the left. This should be N and this should be O. Again, we had a little issue when it was printing. Okay, so it's a rectangle. What is the measure of PON? The angle PON. Nope.
Is it 90?
Yeah, it's 90, okay? Remember, for rectangles, I agree with you, Teresa. If this was a rhombus, it would 100% be 58 because it would be 29 times 2, right? But this is a rectangle. Remember, rectangles, all we know is that all of the angles inside must be 90 degrees and that its diagonals are all going to be the same length, are both going to be the same length. So let's just put that this is 90 degrees. What about PMO? What should this angle be? How'd you get that?
99.
Good. It's just going to be 90 minus 29. Excellent. Nice job, Juliana. $90 minus 29, which is 61. Okay. And PL?
12.
Good. Why?
Because it's the same sign.
Why?
Because there's a bisect. Or the middle, I don't know what it's called. It just splits the middle.
Why does it bisect it?
The diagonal.
Uh-huh. Why? But why? Why do diagonals bisect each other?
Diagonal bisect, but diagonal
Something about the shape. Why is this possible?
parallel.
It's a rectangle.
It's a rectangle, okay? The only reason this is possible is because it's a rectangle. So that means that LO and ML are also that same length. So what's going to be the length of MO? 24. It'll be 12 plus 12, okay? This is only for what shape? Rectangles and squares, okay? Because remember, squares follow both. Squares are like the monopoly of theorems. You can have like so many theorems in squares. Okay, are we good? All right, moving on. Quadrilateral MORE is a square. Woo, it's a square. We get to use all of the theorems, okay? Highlight square. If ME is 7x minus 3 and MO is 6x, how do we find x?
7x minus 3 equals 6.
7x minus 3 equals 6x.
Good, but why?
Because
Because it's a square.
But why?
All sides
Because
are
all the
equal.
sides are the same.
Good. That's what I wanted to hear. All sides are the same. Very good, Juliana. Very good, Marcos. Okay. All sides are the same, so we set them equal to each other. We solve for x. What do we get here? How do we do this? Come on, my algebra people.
Subtract 6x equals 2.
Okay, you can subtract 6x or 7x. I'm going to subtract 7x. What do I get? Negative 3 equals negative x. What do I do next?
Divided by -3.
Not negative 3.
Divide by
Negative 1. Let's divide by negative 1.
Oh, yeah.
And we get x equals positive 3. Beautiful. Are we done? Yes. It said find x. Did we find x? We sure did. Okay, if mt equals 4x and te equals 3x plus 2, find OE. mt equals 4x. te equals 3x plus 2. Find OE. What do we do?
4x equals 3x plus 2.
Mm-hmm. But why?
Because they're all equal.
But why?
If it's a square.
Because,
But it doesn't that only apply to rectangles?
And square.
well, with squares.
Yes,
it-
and
it-
squares. Very good. Very good, guys. Very, very good. Okay? So remember, your diagonals are always going to be equal for rectangles. A square is a form of a rectangle, so it's true for squares as well. So that's why we're able to set these equal to each other. Very good, Teresa. Very good, KL. Very good, Samantha. And how do we solve this? Noah, give it to me. Mm-hmm. Yep. Beautiful. X equals 2. We done? No, why not?
You plug it in.
Good, Juliana. We need to plug it in. So, where should we plug it in? Okay.
In the
We plug it into 3x plus 2. Plug in x equals 2. We're going to get... Okay, we're back. Sorry. 3 times 2 plus 2 is going to give us... Ocho.
8.
So that's what OE is?
No, it's 16.
Ah, it's 16. Why?
Because it's 2 sides.
Good. It's 2 parts. It's the full length of the diagonal. It's all of this. So that would be 8 plus 8, which is 16. So OE equals 16. That's it. Go ahead and turn in your notes.